The spectroscopy of light from Zach Thomas and Nick Brosnahan. The objective for this experiment was to obtain spectra of different types of flora and their corresponding wavelengths from that spectra to compare to the logical and mathematically correct values. So as if you shoot light at a green leaf, then you should get green as your spectra. The tools used in this experiment were very simple, just a handmade spectrometer and white light, either LED or a flashlight. For this we used a white LED light. The handmade spectrometer was made with just tape and a black piece of hard copy paper, so you would roll that diagonally to make both ends pointy, and with a scissor you want to cut one end horizontally and the other diagonally so that it is still pointy. We taped both slits. We taped slits on both sides, as seen in the top right picture, and so that light could, in the bottom right picture, so that light could travel in through the bottom right and then out through the top left, top right. That other object is the diffraction grating that we had to also tape to the rolled up piece of paper so that the light could be diffracted with its corresponding wavelengths. The design of the experiment was also fairly simple. We used a flat surface, and the hardest part was keeping the object flat, a leaf or a flower petal, which is generally curved. So you might possibly break pieces of it, which we actually did many times, so it was pretty hard to accomplish at some points because it also changes the angles. With that being said, the angles constantly had to be adjusted as you move the white light to perfectly hit a spot on the flower that can relatively reflect it at the exact same angle. And most of the time when we did this process, we were in within 10 degrees of the incident ray, which isn't too bad considering that we were using relatively curved objects. I would say we almost got the exact same angles. And you had to do this for each set of objects. So you go from one leaf to a flower. You had to consistently change the reflection angle. The angle of incident generally stayed the same. We might have had to adjust it just if it had fallen or something like that. But the reflection is generally what changed because as you move the object, you have to kind of move the spectrometer device around to get the actual angle correctly. And then once we did, it was photographed, as you can see in the bottom right. The only part that was difficult to design the other part that was difficult to the design was reflection. We chose a pretty poor surface to use, the one in the optics lab, which until the very end I didn't think about, was shiny. It is going to really reflect these wavelengths very well. So that's what you see in the bottom right when you see blue and red. Even though this was a green leaf being shined on, we still see blue and red. Now it did take out other wavelengths, but and when we did the data analysis, we ended up being able to work out the wavelengths that we didn't need, but there was that error. But it is a little evident that if you look at the image, you can kind of tell the green is more apparent and thicker than the other two. They're more consistent, but for this object it was green, and we did get at least some noticeable spectrum from it. For the data, unfortunately for the data, we used an app, and I got one graph from it, but as I tried to use that app for the other 4 or 5 or 3 or 4 images we got, it was not working. We don't know why. The app was gone. I tried to look it up again, but it was nowhere to be found, and so I only ended up sadly with one graph. Um, so most of the angles were consistently between 30 or 40 degrees. It wasn't very propped up or anything like that. This chart is basically a distribution of wavelengths. So what the app helped us do was cancel out. You'll see there's kind of a cutoff point right there between the green and to the left. That's where it kind of canceled out the wavelengths that we didn't really need. It just I set a wavelength limit and it just cut it off right there. So what we really have from this leaf, and this is a different leaf example. This is from a leaf that was red and yellow, and we still kind of see hints of green in there, but the majority of the distribution, the percentage of it is, you can see, is yellow and really red, light kind of in the middle red. There is some orange also, but it's very minimal orange in there. Again, the error is from the surface, so there really was no green on the leaf. However, the surface bounced off all those other wavelengths rather than just the one we saw. And we couldn't really focus any more than we already had without changing the angle so much we were just right up on the object. In conclusion, the most difficult parts were getting the flora to be flat as possible, considering that most of them were natural shaped and curved and bending, and it was difficult to adjust the light to just hit the sweet spot to get those angles correct. And again, the other error came from the table. Was that definitely did not help, having a very reflective table. But the angles and the spectra came out relatively okay, and the approximations weren't too bad, because we still did end up getting, for each leaf, for the green one, we got a pretty thick green spectra. For the bottom image you see here, this was also the image used for the data analysis on the previous slide. This is the image that goes with that. As you see at the bottom, it's very yellow, very red, but there is green and there is blue, which should not be there technically. So that's what the app helped us to do for that specific image, was get out that light that we didn't necessarily need to help wash that out. It is apparent that depending on the color of the flora, the reflected light off it corresponds to the theoretical ones. Like green leaf will reflect green light, and you, again, from the other image, you can see that it is deeper, and from here you can see that there is yellow and red. And even though the blue and green are thicker, they're consistently the same thickness, and that's how also we ruled that it is not supposed to be there. Rather, the yellow and red are the ones that appear to be different. Overall, accounting for human error, the spectra do make sense, and the device definitely worked and proved good results.